Hello, thank you for joining my presentation. Our topic is designing evaluation modules in the VR-based simulation for learners with intellectual disability. I'm Yeonju Tak, the presenter. I'm a master's student in Cheonnam National University in Republic of Korea. This is why we study this topic. Virtual reality emerged as a method to reduce sad cost and risks in real life. It can trail the learner environment to the needs of ideal learners, thereby providing them with a scaffold of profit to the degree and characteristic of the disabilities. For ID students' problem situation, various interface design that can accommodate and consider the specific learning situation should be introduced like observation screen. However, this interface may not necessarily be the most ideal design for a learner with ID because feedback does not respond systematically and quickly. Therefore, it is necessary to find the various cases of the situation and difficulties faced by a learner. So this is our study question: to design and develop an observer control panel of vocational education simulation for intellectual disability learners. Second, to check the usability of the vocational education simulation to which the observer control panel is applied. This is our evaluation module. There are observation screen, and we can check the student performance by using the evaluation metric, and we also give the appropriate feedback when the student faced problem situations. This is the flow chart about our VR simulation. Students enter the name and student number, and they do the job task in the VR simulation. Through the VR evaluation model, the teacher can check and can evaluate the student performance, and the performance data, the evaluation data can save in Firebase. And the end of the task, the teacher and the student can watch the assessment result in Firebase. This is the video of our evaluation module. When students do the task, the teacher can evaluate their performance. They give the score good or fail. On the final page, we can see the score of the evaluation, score of their performance. And the usability analysis by grounded theory was conducted. All processes of using the virtual reality vocational education simulation were found on video, and then SQD was used for the data analysis. The data coding was conducted by a researcher with 4 years of experience as a special education teacher who has observed the current study subject for more than 2 years. Awful coding, Excel coding, selective coding for major features was conducted by continuously comparing and analyzing the recorded video repeatedly. The concept of the codes that appeared during open coding was clarified after a review by one educational engineering expert. Using the observations grid, it was possible to find difficulties in learners' partial navigation, interaction with object, and task performance. Learners showed difficulties in changing direction. The runner gave up moving because they were too close to the wall to obtain information on the direction when the view was blocked. It also showed difficulty in controlling precise positioning, especially in the process of holding the map, which did not fit the object well. The system was also able to provide adequate feedback in the cognitive task area, but it was unable to provide adequate feedback in Space Explorer or grasping object. The third person's point of view made it easy to check the runner's location and stayed even when isolated from the world. So the screen where learner can observe the running situation is effective in grasping the runner's problem situation to hopefully provide feedback and a positive user experience. The following factors must be considered. First, running support for movement and direction change should be included in when designing feedback to increase the VR usabilities. For changing direction and manipulate the object, it is necessary to simplify the key components of the joystick or to get accustomed to it by providing learner with experience in advance.